JavaScript. You love it, you hate it, but in any case you can't deny that it is a fascinating language. It runs on pretty much any device out there, and in fact you're probably using it right now by watching this very video. While it was originally designed as a language to enhance your browsing experience on very simple websites, it has evolved to be so much more. Today it is possible to create fully fledged UIs, backends, and even embedded firmware using the language. So today let's turn to the library that I have written to elevate your coding. Stop it! Stop it! You hate JavaScript, I hate JavaScript, everybody hates JavaScript. I don't know, I'm just trying to film an intro for a video I'm making. What's so bad about JavaScript anyways? The ecosystem, there even is a package called isOdd, which is so trivial I wouldn't even put it into a function. It has over 150,000 downloads each week. Okay, so you've got to be careful you're not needlessly adding dependencies, but other than that, the language has a mess of a type system with prototype-based inheritance, which they finally managed to sweep under the rug with the syntax for creating objects. But now the rug has to be disposed of as toxic waste. And there's so many inconsistencies. Most languages today are trying hard to abandon null values. JavaScript instead decided to introduce something that's worse. They call it undefined. But that's not a normal value. Undefined's just used to indicate a value is unused. That's a normal value like any other. You can set a field in an object to the value undefined. And what do you get when you define a value to be undefined? Contradictory, please explain. Well, you relax. Just write some algorithms in Haskell or something, that'll calm you down. What do you suggest? I mean, real programmers should use real languages like C++, which is best in class for corrupting your memory, or Haskell, which nobody has ever used for a real project, or any of the awesome languages nobody ever uses because just a handful of researchers actually know about them. Ha! I'm trying to learn Prolog, but I can't find any use case or real program in it. Look. Real programmers won't use terrible languages like JavaScript. Real engineers will. Because it makes sense, it runs everywhere and everybody knows how to use the language. But that doesn't mean we have to like it. Exactly, when you need to get some work done, use JavaScript. You can use a proper language for a hobby project. Also, there are some really nice modern features in modern JavaScript. I mean, there's async, there's promises. They stole that from Haskell. They did? Yes, it's called an I/O monad, and that modern feature that was invented in the 60s. Oh, come on, please don't use the term monad while I'm on camera. They're not supposed to know that. Anyway, I agree. JavaScript is kind of a bad language. It has a lot of rough edges, but the library I wrote is trying to solve one of them. It's actually using a concept from Haskell. Is that okay? I'll allow it. So today, let's turn to a little library that I have written to elevate your coding skills. It addresses one bit of JavaScript that is kind of sticking out like a sore thumb. Equality checking. By implementing something very similar to type classes from Rust, we can implement equality checking and we can really do it properly. You can find the original text blog post I wrote about this subject a couple of months ago down in the description. And if you see a reference popping up down in the corner, they're also in the description. So why would you even need to implement equality checking? Doesn't JavaScript kind of have an operator for that? And well, actually it does. It even has two. And neither of them does what you want. Yeah, precisely. Neither of them actually does what you want. There is the double equals operator, which gives weird results. Like an empty array equals 2 or null equals undefined. That's not right. And because that's so obviously horrible behavior, they added a second operator, the triple equality operator. Because why wouldn't you do something as annoying as that? We're in JavaScript after all. And the triple equality operator works. It gives sensible results. Empty array does not equal null and neither does undefined. So the operator can be used to compare primitive values like undefined or null or any numbers. But it can't be used to compare complex values like objects. Strings work though because JavaScript, I know there's a justification for that, but it's still just a weird design choice. Anyway, the reason the triple equals operator cannot be used for objects is this. The operator performs what is known as identity-based comparison. It basically checks whether both objects are at the same location in memory. So stuff like this, comparing two objects, will always return false, because while they contain the same content, they're equivalent, they are not allocated at the same location in memory. What we really need is a function that checks whether both objects contain the same data. Lodash and underscore contain functions for that, but let's implement our own. Okay, so we're almost there. Null and undefined don't actually have a constructor property, so this implementation is not null safe. We could add a special case for those, or we could just let ferrum.js kinda help us. The type function from the library determines the type of any value. It is safe to use here because it will just return null for null values and undefined for undefined ones. The type function from the library determines the type of any value. It is safe to use here because it will just return null for null values and undefined for undefined ones. For anything else, it will behave like the constructor property. This code uses recursion to deep compare objects, arrays, and other values. We just keep using the triple equals operator in most cases and add special cases for some types. In this example, we have special cases for array, date, and object. The implementations for array and object just iterate over all the elements in the container and call equals for each pair. If both containers have a different number of elements, false is returned. If two children are equal, false is also returned. Basically, this keeps searching recursively for a difference in the object trees. Different type, different size, different children. If no difference is found, both objects must be equal. This approach has a drawback, however, because every type we may want to compare needs to be actually supported by our function. What about ES6 map and set types? What about moment.js or a million other types from random libraries? We could manually add support for each of those. I know of one package that kinda tries to do that. It's called object hash, and it is successful at it. But even object hash just supports a handful of node internal types, and that approach definitely won't cover the new account class you're writing for that website project. No, what we need is a solution that is adaptable, something that we can extend with custom types. And luckily JavaScript has just that for us. We can use symbols to define our own protocols, just like the iterator protocol. Now, ferrum.js provides traits as an easy way of defining custom protocols. I won't go into detail about how it is implemented, but traits can be defined for types you don't even own yourself. They can also be defined on null or undefined or even on plain objects, so they are a lot more versatile and safe to use than plain protocols. Now, using traits, we can implement our equals function like this. We declare the trait, provide implementations for pre-existing types using impl, and finally, we provide a wrapper function that just invokes the trait and falls back to using the operator if no implementation was found. For custom types, we can add an implementation just as we would add an implementation for iterators, by using the symbol associated with the trait. So by introducing a concept from Rust, namely traits, we can... That's also from Haskell! Quiet! Shut up! By introducing a concept from Rust, which they admittedly actually took from Haskell, a lot of standard functions can be implemented very well. Other candidates for this are object hashing, getting and setting keys from containers, determining the size of a container, and many more. This concept we introduced, again, traits, is a form of polymorphism. We define a generic interface, the trait, and instantiate that interface for each type that we want to support. This concept we introduced, again, traits, is a form of polymorphism. We define a generic trait and instantiate the interface for each type we want to support. This allows the programmer to forget what type they are working with at this precise moment. All they have to know is that the type implements equals. So when I, for instance, implement equals for arrays, I don't really have to care how equals is implemented for that specific value. All that matters is that I know the value implements equals, be that as part of ferrum.js or in user code. Doing all of this in plain JavaScript would of course be possible, but ferrum.js makes it far easier, far more consistent, null safe, and automates the process. Why do we have two servers at 90-degree angles to each other? This room is weird.